Okay, so thanks a lot for the invitation, very kind invitation. So my name is Jyrki Saarinen, I'm coming from Finland. 2 years ago, I had the privilege to talk here about the photonics ecosystem in Finland. And this year, again, my presentation is different than any of the other presentations. So we have already heard very nice presentations about the fundamental physics, fundamental science. We have talked about the nice applications, and soon already in the morning talked about the third step, which is the innovations. So I'm talking now about the entrepreneurship and photonics innovations, and the examples are coming from the Finnish perspective. And let's go through this before you earn your lunch. So let's define first what are these words. So this is not rocket science, but still it seems that it's difficult. And that's why it's good that we talk. So what is entrepreneur or entrepreneurship? So typically it's a person who organizes and operates in a business. So it's all about the business and taking the financial risk. And typically, commonly we see them as an innovator, a generator of new ideas, business processes, and so on. Steve Blank, who is a very famous entrepreneur in Silicon Valley, says that entrepreneurship is an art, not a job. Why? Because he says that entrepreneurs fit the definition of an artist. So they see things, they create things, something that nobody else does. And also to help to move their vision to reality, they surround themselves with world-class performers. So you cannot generate nice music without the performers, not just writing the notes. It's not enough. Entrepreneurship is getting more and more important nowadays, and even the big companies, existing companies, try to copy. And that's why there's also the word called intrapreneurship, where people in the big companies try to get people to work as an entrepreneur, taking the risks and so on. Of course, they have the company safety network there because they work in the big company, which can absorb losses. So what is then innovation? People are misusing this a lot. So it's not an idea, it's not an invention, it's not a patent. It's really about that you have to be able to transfer that to create value. And the value typically means that somebody is ready to pay for that. So we have a great ideas, we have a great products, but unfortunately not people are ready to pay money for that. And really to be called an innovation, the idea must be replicated at the economic cost. So many times in the labs, we make prototypes, one of components, but to be innovation, you have to be able to replicate that. And of course, satisfy the specific need yeah. There are typically two types of strategies. So what we typically do as a scientist is the technology push. So we start from basic research, we have an idea, and then we try to push that somebody would use that somewhere. Of course, let's say the better or let's say the higher probability is that you first understand that there's a market or demand pull. So you understand there's a need, there's a problem. And then you start thinking about how you can solve that. Can I use my know-how, my technology to solve that? Of course, that doesn't mean that this is the only way. So technology push is also correct, because otherwise Henry Ford said that if I would have asked looking for the market demand pull, people have just asked to make a better horses or faster horses. So there's also the technology push has its room. So I'm encouraging the scientists usually that saying that every single phenomenon, new thing that you find in your lab has a business opportunity, for sure. But the challenge is what is the product, what is the service that you can create out of that? Where is the market, the industry who is going to use that, and who are the customers who are actually going to pay? But I will say that for every phenomenon there is a market opportunity, but it's very seldom that we actually find that. Another important thing is also when. It may take, let's say, hundreds of years before actually you can find the application. So even people understood how to make fibers, what is the waveguide phenomenon, total internal reflections. It took a long time before then we started understanding where we can use them in a medical field. It even needed another technology, coherent light source, before we were able to start using fibers in optical telecommunication and make a revolutions on that. So the when is also an important thing. So you have to understand that, let's say, it may be the right time window. And this is a difficult process. So a professor from Harvard Business School studied that at some point that there are about 30,000 new products introduced every market. So that means that the companies have already decided that there is a need, and they have spent maybe a couple of billions to make the product, and they launched the product. So 95% of them fail. So it is not that easy, even the existing companies, and I guess also that for us as scientists. So even you are working hard, and anybody who's working in the startup is working hard for the product, finding the technical challenges and so on. The majority of the startups still fail because of the lack of customers. And that's why, let's say, the following things, what I introduced, are important. The good thing in photonics is that there's a lot of possibilities, because we can now use light, laser sources, whatever, LEDs and whatever, in so many applications. So there's a plenty of areas where we have possibilities to find great new innovations. These are some of the examples of photonics and photonics-enabled companies in Finland. So we are doing pretty good work. So we have some nice exits already. Big companies have acquired. This is not only negative, because the companies still stay in Finland, and they even get more in investments and so on. From Modulight to Kellu, there are companies who have already, I would say, been able to make an innovation because they have a product, they are already paying customers. But there are also some big companies which are working in the field of photonics. And I have had a great pleasure to be involved in some of these success stories as a co-founder, or, for example, as a board member. Photonics in Finland is also doing well. So actually, we are just today starting a new market survey for 25 or 24, but this was published in 23. So we have about 300 companies working in the field of photonics, about 2 billion euro revenue, 6,000 employees. But the most important thing is really about the growth figures. And this is the third time we made this since 2016. And every time, actually, the real numbers have been even more than what the companies forecasted. So that means, again, that there's a huge potential possibilities to make innovations in the field of photonics. So I don't talk about your technologies. Of course, we need a good product, a good idea, for sure. But I'm leaving that to you. So let's talk about the other key factors, which are maybe not that well understood. So I would say that one thing is the team, because as a scientist, you work even yourself, or you have a small team. But in innovations, it's all about the teamwork. Like Steve Blank said, that you need a world-class performance. You need funding. You cannot do this free of charge. And I would say that the government policy is also something that really, let's say, motivates us to work on this. So what are the important things in the team? I would say that of course, it's again, they have to good researchers or good engineers and so on. But they also need to have the right mindset. That is even more important. And also the mix of different skill sets. We already heard about that. You have to kind of combine different kind of skills, because it's not, if you just take 10 scientists and try to make business with them, no way. You need to have a commercialization, standardization, quality control, sales, and so on, management. About mindset. I usually say that startup and existing company, even the startup is of course officially a company, they are two separate things. Because as a startup, when you are still in the innovation path, you are searching for business. You are looking for the product market fit. You are trying to find a repeatable sales model. You are working in a chaotic environment, a lot of unknowns. Are they interested or not customers? You take a lot of risks. You have to be able to make and understand that you are making mistakes. And that's completely different if you look about what the existing companies have to do. They execute their business model. They have their quarterly or annual plans, what they are supposed to do. They have to be profitable. They have to avoid risks and mistakes. So the mindset is completely different when you are in the innovation path or when you are in the existing company. What the challenge is also that if you look about, this is from Ken Singer from Silicon Valley, if you look about how we educate our students and what you need as entrepreneur, unfortunately, these are really different things. I don't mean that the person from the university cannot become a good entrepreneur, but you have to understand that the mindset has to be different. You cannot look dumb. You must be able to make risks and mistakes. Culture of perfection, culture of where good enough. Tested individually, rewarded as a team. So very different mindset again, how we teach the students. About the mentors. This is the study from US MAC, which is a US Market Access Center, an accelerator in Silicon Valley. So they have studied that actually you have to have also mentors. So after the discovery and validation phase, when you start scaling up as a startup, the big difference is about whether you have a mentor. So mentors are people who have done these things before. So that's the difference. So you have to have also certain senior people involved. You need money. In Finland, I would say that we have a good situation with the money, and that's why we have also a lot of startups. These are the investments into Finnish startups, which is a very new results. And it has been growing steadily. What we are also very proud that we have also foreign investments. So about more than half of the investments are coming from the abroad. And also we have a Finnish others, that's for mainly families, rich families, business angels, and so on. So in that sense, we have a good situation. The challenge in Finland is that we lack funding for growth, for scale-up phase, for growth phase. So too many times the startups are then acquired by foreign companies too early, so they cannot anymore grow with the Finnish money. Fortunately, the government has decided. So, for example, the government is putting 100 million in 3 years, so 300 million more money to government funding for the scale-up phase, and they are expecting that now the fund is about 1.8 billion euros, and with the private money, they are expecting to have a 12 billion euro for the scale-up phase also. So, fortunately, hopefully that will help. About the government policy, we have a very good tool from Business Finland, which is the main funding organization from the government for the companies and applied research. So they have a program called Research to Business. And this is the money for research teams at universities when the research is still at university. So for 1 to 2 years, they give money about 300,000 to 700,000 euro for the research team at the university. They have to spend more than half of the money for, let's say, finding out whether there's a commercial opportunity for the idea. Half of the money can be spent for developing the technology or the product. But the good thing is also this is good for the students or the people who are at the university. They have 2 years to start thinking about that. Could I leave the academic world to become a person working in the industry? So this is good for them, because that's also the problem many times. What I have seen, that if there's a good innovation in the university then there's nobody who wants to kind of start commercializing that, because in one day you would have to leave your academic, let's say, safe world to the industry. So here you have a 2 years time. So quite many of these startups, what I kind of showed previously, are born from that program. So it's a very good one. We have also this flagship program. So the government, even the academy or the Research Council of Finland understood that, or they are putting money also for the not only for the high level science, but also science which has an impact. So in Finland, the government started this flagship program which are evaluated from the impact and science part science separately. And they granted this also, for example, for the photonics, where we have three universities and the VTT as a research center, and we have more than 500 staff people working on various kinds of applications. And there we are also working a lot also with the collaboration with the industry, helping the startups and all this innovation part. In Finland also, the key thing is that collaboration. So when the BRAIN flagship program increases the collaboration between the three universities and research center in Finland, actually forcing them to work together. InnoCities program is financed by the Ministry of Trade and Economics, and they are forcing the cities to work together. So we have, for example, the InnoCity program. There are lead programs, and one of them is the Photonics Innovation Ecosystem, and there Joensuu, Tampere, Oulu, and Espoo, the capital region, are kind of forced to work together, where the policymakers of the city level are also, let's say, collaborating, not competing. And then, of course, the Photonics Finland is an important organization. So here we don't have a separately industrial cluster and scientific society. We have merged them together. So we have here both about 400 scientists and students as members, but we have over 100 companies as members, and also all the universities as a last row, all the universities which are also working on photonics. So this is also very, very important, again, for the collaboration and the collaboration with the industry and so on. And I would like to advertise two things. So we are going to have these Optic and Photonics Days in the beginning of June in Oulu. We have parallel sessions on the science and industry, and people can jump from one session to another one. The topics in the industry will be medical technology, automotive, machine vision, and sustainability, and of course similar things in the science part. We are expecting about 400 people there, and then we have also exhibition where we have 41 companies presenting their cases. And of course, we have a job fair, student meetings, we have the BRAIN Photonics flagship annual event, and so on, many other things. So a great place to network and learn about the applications and the companies, their needs, and so on. And then also another thing is that we are organizing a summer school every year. And this year we wanted to focus on the innovations. So it's about the innovation skills in photonics. We have a great lecturers, Heikki Immonen and Anna Gebeyes, and then we have also a guest lecturer from NASA, an astronaut who has been also working with a different kind of, let's say, teamwork in NASA and so on. So you're also welcome to join this in the third week of August. So thanks a lot. You have now earned your lunch.